Today I'm going to be talking about the law of sines. So up until this point, when we've been doing trigonometry, we've been doing right triangle trigonometry, which means that it requires a right triangle in order for us to use the trig functions of sine, cosine, and tangent, the SOHCAHTOA that we've been using up until this point. So this video is going to be about the law of sines. And in order to use the law of sines, we need an oblique triangle, which means that it is not a right triangle. So I'm going to go ahead and draw a triangle here. And this is not a right triangle. This is an oblique triangle because I have not put any right angle tick marks on any of these angles. And we're going to call this triangle A, B, C. So I have angle A, angle B, and angle C marked clearly here. So we're going to be labeling the sides that are across from each of these angles. So across from A, if I go directly across, I see this side. So I'm going to call that side A, or lowercase a. Here's B. Right across from angle B is what we're going to call side B, or lowercase b. And C, across from angle C, is side C, which we'll denote with a lowercase c. So we can use these labels, like when we say put your model on the triangle, we can use these labels. However, it might be a little bit more difficult, especially if we have triangles that are labeled with 3 different letters already that are not A, B, and C. So what I find even more helpful is I like to color code these. So I'll say that this is angle A. I'm going to denote it with a green tick mark. And across from angle A is side A. I'm going to denote that just also in green. Here's angle B. Right across from side B. And then here's angle C, right across from side C. So I find it more helpful to color code these because I can really clearly see, like, oh, these two go together, these two go together, these two go together. And the reason that we're doing that is for the ratios that we use in the law of sines. So the ratios, or the extended ratio that we use for law of sines, is the sine of angle A over the measure of side A equals the sine of angle B over the measure of side B. That's why we do math in pencil. Equals the sine of angle C over the measure of side C. Right, so this, I'm gonna zoom out here. This is the law of sines, right? That when we have a ratio between the sine of the angle and the across side, they're equal to each other. So we don't need to use all 3 of these ratios. We just need to use the 2 that are the most relevant to our problem. So for example, I'm going to look at this worksheet, and I'm going to zoom back in a little bit. So for number 1, I need to find the length of AC. I'm also going to move this around a little bit so that I'm not bleeding through my paper. I need to find the side length of AC. So I'm going to color code. This is what I'm looking for right here. And that is, it'll focus, that is right across from that angle right there. So we could call this side B if we wanted to. We're looking for side B because it's right across from angle B. So we also need some other, in order to put together those ratios, we need some other information. So let's use this one. We'll say because AB is across from C, so we'll connect those 2 together. Those are the blue ones, so those will be in the same ratio. And we'll use purple. This angle A right here and this side CB those will also be in the same ratio. So purple goes with purple, green goes with green, blue goes with blue, right? In order to do law of sines, I need one complete ratio. So that means I need both colors for one of these things to have information for me. So if I look at this purple angle, which is 118, that gives me a number. And I look at this purple side, that purple side doesn't give me a number. I have no way of figuring out what that purple side is without using some additional information. B is what we're looking for, and that's green, and that corresponds with that 22. But that's what we're looking for. That's not what we already have. We need one complete ratio of information that we already have. And then we look at the blue pair. So we have this 24 and then this angle, this missing angle. Well, we know from our previous rules in geometry that all three angles in a triangle add up to be 180. So we can use that rule in this case to find our blue angle. So I'm gonna, on my calculator, go 180 minus 118 minus 22. And that's gonna leave me with 40. So this angle right here has to be 40. So now I do have one color that's like both the angle and the side have numbers that have information for me. So I'm going to take the sine of the blue angle. The blue angle is 40, so I'm gonna take the sine of 40 over the blue side, which is 24. I'm gonna label this. This is my blue ratio, right? I have both information of the blue color. And now I'm looking for green. So I'm looking for a green side, so I'm gonna put sides on the bottom. So I'll put B on the bottom for the green side, or AC. And then the corresponding angle that I'm gonna take the sine of is 22. So I'm gonna write sine of 22, and that's my green ratio. So I have one complete ratio where I have both information and one incomplete ratio where I'm looking for B, right? I don't even have to worry about the purple one right now because this will get me the information that I need. So now that I have this proportion, what do we do with proportions? We cross multiply. So I'm gonna cross multiply. I'm gonna take the sine of 40 times B equals the sine of 22 times 24. Well, I want B by itself, right? I'm looking for that information by itself, that side by itself. So I need to get rid of that sine 40 by dividing it by both sides. Then I'm going to cross this out, that cancels out, and I end up with B equals the sine of 22 times 24 all over the sine of 40. So that's something that I can plug into my calculator. So making sure that my calculator is in degrees, not radians, I'm just gonna plug that in. So sine of 22, close my parentheses, times 24 divided by the sine of 40, closing my parentheses, equals 13.986, whatever. So rounding to the nearest tenth, that would be B is approximately 13.988. That would be approximately 14. Right, so that's how I find all of that information. All right, I'm gonna do another problem, but this time I'm gonna find an angle. So we're still using the law of sines. We're still using those same ratios that are found in the law of sines. I'm gonna go down to number 6, where it says find the measure of angle C. So again, I'm gonna color code these. I know I'm looking for angle C. Maybe let's make that purple. And that's right across from AB, right? There's my 6 right there. These 2 purple ones, one of them's missing. That's the one that I'm going to be looking for. I also have angle B is right across from this 24 right here. And I have that angle A is right across from this 26. So now, again, I need one complete ratio. That means one color where both the side measure and the angle measure are filled out. So I'm gonna look, so the purple one is the one that I'm looking for. So I'm gonna be looking for C, so I don't have it already. For the green ones, I don't see any information by B, and I don't see any information by C, so I can't use that rule that was previously taught about all angles in a triangle adding up to 180, because I don't even know what C is. But I noticed that angle A is 103, and side A, the blue side, is 26. So that's an angle and a side that are both filled out. So I'm going to use that ratio as my complete ratio. So sine of the angle measure, which is 103, over the side length, which is 26, equals, and now I know that I'm looking for purple. I can even color code that in the question if I want. So I'm going to use the purple ratio, which means I'm going to put sine C on top because I don't know this angle measure, and on the bottom I'm going to put 6 because that's the purple, the corresponding side measure. All right, now that we have a proportion, cross multiply. So I have 26 times sine C. You could put sine of X if you wanted to, if that helps you remember what to do next, equals 6 times sine 103. So again, I want to get my C by itself. So I'm going to divide both sides by 26 to get rid of it here, to cancel it out. So then I have sine C equals 6 times sine of 103. That is my workforce prep textbook. Not that one. All over 26. So I can't plug sine C in the calculator. I want C fully by itself. So one more step before I plug this into the calculator, because the angle is unknown, I'm going to use the inverse of sine, or it looks like sine -1 in the calculator. And then in the parentheses, I'm going to put 6 times sine of 103, closing the parentheses as appropriate, over 26. So the way that I like to do this is a little bit different from the way that McAfee does it, because I like to use the answer button. So to plug this into the calculator, I start with sine, the inverse of sine, so sine -1. And then I do 6 times, oh, sorry, that's not what I do. I'm gonna do 6 times sine of 103, close my parentheses, and divide that by 26 equals. I'm gonna keep that in my calculator. I'm not gonna clear that. And then I'm gonna do sine -1 of the answer, close my parentheses, and I get 12.9943, blah, 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 blah. Rounding to the nearest tenth, that's angle C. Measure of angle C is approximately 13 degrees. Sorry, I said that I was going to do number 6, and it turns out that I did number 8, but that's okay, because I did the full question for number 8. So that's all of the steps that we would go through. So like this would be how you would demonstrate mastery of the standard on a question where you're looking for the angle. this would be how you demonstrate mastery of the standard on a question where you're looking for the side. So my next video is going to be about the law of cosines, a lot more heavy-duty formula. It's going to take a lot more practice, but that is how you use the law of sines.